All right, so we are picking up with number 28. These say, find the polynomial function with the leading coefficient 2 that has the given degree and zeros. So essentially at the end, we're just going to take whatever we have and multiply it by 2. So it is degree 3 with -1, 3, and -5 as zeros. So this means that the terms are going to have the opposite sign. So we're going to have x plus 1 times x minus 3 times x plus 5. Because essentially these are x equals each of these things, and that's what it means for them to be zeros. So to actually get the factors, we'd have to do it that way. So then FOIL, I'm going to FOIL the first two. What do I get?
You get x squared. Well, I'm going to do it.
X squared minus 2x plus, or minus 3.
Yep. And then multiply by x plus 5. What do I get when I do that?
X cubed minus 2x squared plus, minus 3x plus 5x squared minus 10x minus, or not minus, yeah, minus, 20. No, that's definitely wrong. 15.
Yep. And then I just need to combine like terms. So x cubed plus 3x squared minus 13x minus 15. Now the instructions said I had to have a leading coefficient of 2, so if that's the case, then I need to multiply this entire thing by 2. I don't just get to throw a 2 out front. So my final answer would be 2x cubed plus 6x squared minus 26x minus 30.
Why did you multiply by 2?
Because the instructions said I had to have a leading coefficient of 2.
Oh, okay.
So if there doesn't end up being a 2 here, then I need to just multiply the whole thing by 2.
Okay.
I don't really understand why they put that stipulation on there. I probably wouldn't if you had it on a quiz or a test, because it's excessive. There should be stuff in college algebra and algebra 2, I think.
Yeah.
Things there in the pencil by my mouse. There might also be stuff in algebra 1.
Yeah, there's something like the third box, which I'm pretty sure is that class.
That's probably pre-cal.
Yeah.
But I think anything that's paper clipped you've already checked, so anything that's not paper clipped is all that needs to be checked. All right. Next one, use the rational zeros theorem to write a list of all potential rational zeros. So this is very specifically, we're just writing out the possible ones. And then it says determine which one are zeros. So we're actually doing 2 things. Essentially, determine which ones are zeros. So 34, we have f of x equals 3x cubed minus 7x squared plus 6x minus 14. So when we're finding all possible zeros, we do factors of the last term over the factors of the leading coefficient. So it'll be factors of 14, and it can be, I'm going to put negative 14, but it's going to be the plus or minus ones because we don't know which ones it's going to be yet, over the factors of 3. So factors of 14 would be plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. Factors of 3 are just 1 and 3, so plus or minus 1, plus or minus 3. So now I actually have to go through and list all of them. So they all of it, like, first are just written over 1. So I'm not going to say plus or minus every time, but know that they're plus or minus. So 1, 2, 7, and 14. And then I do them each over 3. If it's not going to happen in this case, but just so I say it now, if there's ever a repeat where, like, if you reduce something and it got to something we've already written, you don't write it again. So 1/3, still all plus or minus, 2/3, 7/3, 14/3, and do not make them mixed numbers, leave them as improper fractions. So this is all possible ones right here. So that's, okay, turned it into a box. So that's the first thing that it's asking us for. Now it wants us to check and see which ones are potentially zeros. So on your calculator, in y equals, you're going to type in this function that we started with. And you're going to graph it. If you have a stat plot on, you're going to have to turn it off, but I don't think you do.
Do you have a calculator charger?
Wait, you press graph? Or press-
Zoom 6. All right, so at that point, once you have it graphed, you're looking to see approximately where it looks like it has crossed here. So it looks to be a little bit more than 2. So I want to look at my fractions that I have and see, are any of them a little bit bigger than 2? 7/3, and I need the positive one. So I'm going to check 7/3. And we do that with synthetic division. So we put 7/3 in the box. We copy down the numbers just like we were doing at the beginning of this section. If a number is missing, we need, like, if a term is missing, then we would need to put a 0 in. We don't have any missing for this one. So 3, -7, 6, and -14. So I bring down the 3. Multiply by 7/3, that gives me 7. Minus 7 is 0. Times 7/3 is 0. Bring down this, so then add that to 6. 6 times 7/3 is 14. 14 minus 14 is 0. So that means that it is, in fact, a 0. So 7/3 is 0. Just ring a bell from last year. All right, 36, so another one of these. F of x equals 6x to the 4th minus x cubed minus 6x squared minus x minus 12. So first of all, I need factors of 12 over factors of 6. And again, they're all plus or minus, but I'm going to avoid saying it. So what are the factors of 12?
Plus minus 1, 2, 3, 4, 6, 12.
Yep. And how about for 6?
2 or 1, 2, 3, 6.
Delayed reaction there. So this one looks like it's probably going to have a few more things for me to write down. First of all, I write them all down as over 1, so I'm just going to be recopying the top row. Then at this point, I do all of them over 2. If there's anything that's repeated, I don't write it again. So I'm going to have 1/2. 2 over 2 is 1, which I already have, so I don't need that one. 3 over 2. 4 over 2 is 2. I already have that, so I don't need that again. 6 over 2 is 3. Already have that. Don't need it again. 12 over 2 is 6. Already have that, so I don't rewrite any of those. Over 3, 1/3. 2/3. 3 over 3 I already have. 4 over 3. 6 over 3 I have, and 12 over 3 I have. And then lastly, we do stuff over 6. So 1/6. And then I've got 2 over 6 is 1/3, already have that. 3 over 6 is 1/2, already have that. 4 over 6 is 2/3, already have that. 6 over 6 is 1, and 12 over 6 is 2. So these are all possible here. All right, so now put that function in your calculator and graph it, and we're going to see where it looks like we have some potential ones that may work. Which ones look like they might work? Thank you. Three over 2. Any others? We're looking for everywhere that it crosses the x-axis. -4 over 3.
-1.
Yeah, it's possible. That one, it's kind of hard to tell. It's probably a little bigger than -1, but it's always worth writing down. I would start with the one that you think it's the most likely to be. So I know that according to my graph, I see 2. How many could I potentially have based on this function? 4. So it either might mean that some are repeated or that some are like non-real zeros. So I'm going to start out with 3/2, I think, to check that. So 3/2 in the box. 6, -1, -6, -1, -12. No terms were missing, so don't have to worry about that. So bring down the 6. 3/2 times 6 is going to be, what was that, 9? -1 is 8. Times 3/2 would be 12. -6 is 6. times 3 halves is 8, minus 1 is 7, nope, yep.
Is that
Wait,
9?
something's not right. What?
Should be 9.
Yeah.
9, thank you. I was like, something's not right. So then that would be 12, and that's a 0. Okay, so 3 halves works. So x equals 3 halves is one of them. Then negative 4 over 3. And now once you've like confirmed that this is one, I can now use these numbers instead of having to start like back from the beginning. Because this essentially was an x to the 4th term. This is now an x cubed term, so I can just keep working down. So 6, 8, 6, 8. Bring down the 6. 6 times that is negative 8. That's 0. Times that is 0. That's 6. Times that is negative 8. That's 0. So that one also works. So x equals negative 4 over 3 would be the other 0. So more than likely the other ones are non-real zeros, which is why it's causing it to look like that. But anyways, those are the two that we can see. So those are the two answers that it's looking for. Any questions on those?
Are we gonna get a quick one?
Yes,
I was asked that.
I was going to. I just wanted to finish the problem first.
First one, like, you didn't get one in trig last year, I don't think.
Last year we had like 2 cookies. We didn't have any.
Actually?
Yeah.
No, last year we bought it. We just didn't get the cookies.
Because nobody would ever tell me what cookies they wanted.
I thought we did. What did we bring food in for?
Pi Day.
Pi Day was so much fun. That was most of the time game Uno in my life.
I literally kept saying what cookies, and nobody couldn't decide on cookies. So,
Just get like the Walkhouse ones.
huh?
The Walkhouse cookies.
Just about like Costco cookies.
I don't even know what those are. I don't have
They're like the
Costco
sugar
membership.
cookies, like the ones you get from the store.
They're
but
really
it's
soft
ones.
All right. Let's see. Next thing. Use synthetic division to prove that the number k is an upper bound for the real zeros of the function f. So if all of the numbers come out positive at the end, or hold on, let me see if it's positive or non-zero. I don't remember. Positive or 0, so they just can't be negative, then it's an upper bound. If they alternate positive, negative, positive, or let me say this because it can be 0, non-negative, non-positive alternating, then it is a lower bound, which we'll do one of those in a second also. So they give us that k equals 3, f of x equals 4x to the 4th minus 6x cubed minus 7x squared plus 9x plus 2. So I put this number that they give me for k in the box. So then copy down all these numbers. Still, if there's one missing, I would have to put a 0. So 4, negative 6, negative 7, 9, and 2. To bring down the 4, times 3 is 12, minus 6 is 6, times 3 is 18, minus 7 is 11, times 3 is 33, plus 9 is 42, times 3 is 126, plus 2 is 128. So everything going across here is non-negative, so it's either positive or 0. So therefore, 3 is an upper bound. Then if I want to show it's a lower bound, 44, k equals negative 4, f of x equals 3x cubed minus x squared minus 5x minus 3. put -4 in the box, copy down the numbers, 3, -1, -5, -3. Bring down the 3 times -4 is -12. Minus 1 is -13. Times -4 is 52. Minus 5 is 47. Times -4. Wait. 188. Is that right? Yes, okay. So then negative 191 would be the solution. So this is non-negative, non-positive, non-negative, non-positive. So because they are alternating, that means that -4 is a lower bound. Any questions on that? All right, what was the last problem I gave y'all on Friday? 21. Okay. So in addition to what I gave you, you need to add on 27, 35, 39, and 41. So that's one of each type that we just did today. Added on to what you had the other day. All of it will be due tomorrow. Have a little less than 30 minutes today. And we're quizzing on 2-1 to 2-4 on Wednesday. I don't know if it's up on the board or not. I can't see. I think it is.